Ladies and gentlemen, good afternoon. Thank you for the opportunity to join with you today. Of course, for those of you who don't know, it's actually the longest day of the year. And as a lighter and a fan of daylighting, that makes me very happy indeed. Maybe not so happy that we're inside, but happy nonetheless. I'm also very happy to be able to mark and celebrate 40 years of the Environmental Design Engineering MSc and 30 years of the Light and Lighting course, both accredited by my institution, CIBSE. I'd like to start by sharing with you a cartoon that got me thinking about a subject that is very close to my heart, which is change. So if you can imagine, the first slide of a cartoon is very much like the scene we have today. Somebody at a podium speaking and a full audience, and the first question is, who wants change? And in the audience, every hand goes up. Every hand wants change. So we go to the second tile of my cartoon, and the speaker poses the question, who wants to change? And the eyes go down, and the speaker notices that there isn't big appetite for people to change. And then the third tile is, who wants to lead change? And the speaker at the podium stands on her own because the audience has left. And I think that, to me, is a very telling point around change. Change is disruptive. Change can be positive, and we try and lead positive change within CIBSE, but of course that disruption can also be uncomfortable. And I think we all know that we're living in a time of immense change, aren't we? I mean, we have immense geopolitical change with nations reasserting their relationships with each other, none more so than the UK as we approach Brexit. And we have, as you all know, environmental challenges and the change that brings on. Last year, global CO2 emissions rose to an historic 32.5 gigatons. In the same year, the cost of climate-related disasters such as hurricanes, monsoons and floods rose to an historic £200 billion. And this change we see also in terms of technology. And when I speak to my colleagues in the industry and talk about understanding these impacts of change, almost to a man and woman, they talk about the changes that we will see from changes in technology. And certainly there's an OECD report out this year that 14% of the jobs currently being undertaken by human beings will in the very near future be undertaken or carried out by robots. And the shape of our built environment is changing also. Economic pressures on the construction sector, and I'm thinking of Carillion of recent times, and a recent government report saying that the transformation required in the construction sector will become a very big challenge in the near future in terms of the performance of our industry. If we go back to our cartoon and we ask who wants to change, we need to look at ourselves. And certainly from our professional engineering institutions. John Uff QC recently carried out a sector report where he identified the lost 3 million. So those are the 3 million people that could be a member of an engineering association, but chose not to. And I think that is really, really important, because one of the challenges that not only our institution, but I think all of the professional institutions face is the importance of relevancy, and to both maintain and grow our reach. And I think that is, without wanting to give you the big sell on CIBSE, but I think it is one of our great strengths, that as well as a traditional building engineering institution, we also have specialist disciplines, none more closely aligned to the Bartlett than the Society of Light and Lighting, but also disciplines in facade engineering, public health, local exhaust ventilation, and most recently digital engineering. And I think that then starts to work cross-disciplinary and collaboratively, not only with our institution, but more broadly. CIBSE has 24 special interest groups. Half of those are not CIBSE members. And I think that's hugely encouraging, because what it actually demonstrates is that we are not just talking to ourselves. We are wanting to grow our relevance beyond the institution. CIBSE is really thinking about why. It's thinking about our purpose, why we exist. And we exist for the public benefit. And we are committed to being at the forefront of leading positive change. The questions, of course, are how we adapt to change. And we've heard our speakers this afternoon already talk about collaboration. And I think one of the ways to lead positive change and to mitigate some of the disruption is through collaboration. And as Tony Day has mentioned recently, that collaboration will mean that we can share the costs of that innovation across the supply chain, and we can make those incremental improvements more quickly. Everything that we do as an industry can make the built environment better, whether it's through the products that we make, the projects that we design, the buildings we manage, operate, maintain and refurbish, the codes and guidance we write, or the standards and regulations we contribute to and consistently help improve upon. And I think if we ever needed to understand our why, the recent tragic events at Grenfell Tower in London remain very close to our hearts. And I'm proud that CIBSE has worked very closely with the ongoing work that the inquiry will produce. Together we are a force for good that seeks to enable positive change, and we have the ability to respond for the good of the people who live, work, and enjoy the spaces we create. I'd like to thank you all for your leadership, both now and in the future. Thank you. It's now my pleasure to chair the opening session. Our first speaker this afternoon is Ricardo Moreira. Ricardo is a co-founder and managing director of XCO2, a 50-strong MEP and environmental engineering practice in London and Singapore. Ricardo is responsible for the company's overall management and strategic business development, and also leads some of its key international projects. He is an EDE graduate from 2004 to 2005. Ladies and gentlemen, will you please welcome Ricardo Moreira.
Well, thank you very much, Stephen. I would like to thank Hector and the EDE course in general for the invitation. It's a real honor to be here. So when I was invited to speak today, I was actually thinking about what I could talk about when I perhaps some of the projects we work on, some of the research we're doing, but I actually thought it was much more relevant given the commemoration of 40 years of EDE to talk about the EDE people that we have in the company. I think we are quite unique in the sense that a huge part of our workforce is EDE alumni, and we're actually very proud of it. So that's what I'm going to talk about. I'm going to talk about the people, the EDE alumni in our company, and some of the work they're doing to give you a flavor of EDE at work, meaning how do we as a company put in practice a lot of the stuff that we learn during the course, and just a bit more about the background of these people. I wanted to start with the unique things that I felt about the course when I did it 14 years ago was diversity in backgrounds of people. At the time, it was only 25 people, as Dejan said. Obviously, it's changed, but it was very much people from all sorts of professional backgrounds, and that was really interesting because in the industry afterwards, I really felt like that gap in collaboration between architects and engineers needed to be bridged, and I felt the course went a long way in doing that. Myself, as an architect by training and practice before, wanting to move into engineering, it was actually the perfect course to facilitate that change. But I also saw a huge diversity of backgrounds there. International diversity is amazing, and I think that really only could happen in a city like London. I'm not from here, and the greatest majority of you guys are not from here, and that is fantastic because it really brings a lot of different perspectives. And finally, diversity in terms of the modules and the disciplines that we studied in the course. It was such a broad course, but at the same time, never superficial. It went to the right level of detail. So anyway, and these three things I think are actually reflected in our company. We are very diverse in terms of backgrounds, international and professional, and we actually work on a lot of stuff. So here's us. At the moment, we have, 10, thereabouts. So it's about 20% of our workforce. And you recognize some of your colleagues here, and we actually have some current ED students at the moment. Really be part of the presentation. I wanted to actually bring them all here, but honestly, it's a bit difficult. Some of the stuff that we do is actually, talking about the diversity of services that we provide. We started as an M&E and energy consultancy, and over the years, we're actually tonight celebrating our 10-year anniversary event too, so it's actually momentous for us. But over the years, we've actually expanded into a number of different other services, and we continue to do that, bringing in additional environmental services in-house, but really to try to have that kind of collaboration of services. Picking up on what Professor Allen talked about, kind of the sum being more than just kind of the addition of the individual parts. Some of the work that we do is actually quite diverse as well in terms of sectors. As I said, there's quite a lot of reflection upon the kind of work that was done at the EDE, both in terms of tools, but also approach and areas that we analyze. And and this is what we like to be about. I know that's really kind of our guiding mission, I suppose, is really to reduce the environmental impact of projects with project-specific solutions, but really kind of modeling and quantification are key. There's our industries and professions suffer for a long time from lack of precision and quantification, and we wanted to actually be able to demonstrate to our potential clients the benefits that they can achieve, but really team collaboration and really crossing that barrier of disciplines. So that's me. I'm from Brazil. I graduated in 2005, and I'm an architect. And I'm going to start talking about a project I've been working on for the past 8 years, I think. It actually started as a pro bono job, and it's my favorite project. So this is a school for Buddhist monks in the Indian Himalayas. We were approached by the people who manage this 400-year-old monastery in the back of the picture there, and at the front you've got a rendering of what this school is going to look like. But the most interesting aspect of this project was actually the challenge of the climate and the extremes of weather and climatic conditions that we had to deal with, and really trying to apply passive measures and to really make the building work throughout the year, depending as little as possible on active systems. So there was a lot of work done with the design team, and again, trying to foster that collaboration with architects and trying to shape the building in terms of location of various functions, but also the actual orientation and configuration of the building. We had some really interesting elements there. So a lot of earth sheltering work. We use trum walls, which are actually currently under construction, which is very exciting, which is a concept from about the time when the EDE course started, but it's been really seldom used. So it's a really interesting thing to see it in place. And then there's actually solar latrines down here, which we used. It's been a traditional solution in certain climates, but not usually developed with the aid of computational fluid dynamics and dynamic simulation. So that was an opportunity to do that. And again, this is under construction, and we used a lot of those tools to help us design things. So this project is actually under construction, and we'll be talking more about it when it's done. This is just a rendering of what it will be looking like, hopefully, in 2 years' time. Some of you guys might know Kostas. So Kostas came from Greece, had a thirst for knowledge. He's actually a structural engineer by training, and graduated a few years ago. And Kostas actually brings a very methodical approach to the work that we do. And one of the projects that he worked on recently is the new Fetter Lane project by Great Portland Estates. So this is a recently completed 12-story tower in the city, and we're brought in to look at post-occupancy evaluation of this. So this building during the design stages actually performed amazingly. It was getting all the best EPC, BREEAM, whatever you want, ratings. But in effect, in practice, it was actually performing really badly in terms of the amount of energy consumption. Nothing new. You guys are, I'm sure, aware of the performance gap, and through some of the work that we did on Carbon Buzz, that was actually very clear. So there was a lot that was looked into this, a lot of CIBSE methodologies used on the POE here, but some of the interesting things were not so much technology related, but they were more in terms of occupancy and controls, and really trying to get the building services to align with the way the building was going to be used. And some of the solutions that were proposed afterwards were very much to do with simplification of controls, with in-house training, with, in effect, just using the BMS system, which is highly advanced but never touched and never really configured for the building itself. So our hope is that this has actually been recently completed, but our hope is they'll be acting on it, and it's nothing really that costs any money. It's basically making good use of the technology that's there, but also trying to understand how occupants are going to use this building. And when we look at industry standards like Bezier soft landings and other POE and BPE methodology, it becomes very clear that there's so much that can be done on the kind of soft side of things rather than equipment-wise. Right, meet Thelma. Thelma is from Brazil as well. Her background is actually she's a biologist and slash interior designer, so she actually did 2 courses. Graduated a few years ago. Thelma's got a very broad view of environmental performance, and she's really interested in BREEAM. And she worked on this unique project for Costa. We actually work a lot with Costa, which is not the most sexy of clients, but they're really, really interested in energy performance of their stores, and they're building loads of stores at the moment. But this one was a flagship one for them because they wanted it to be quite unique in terms of performance. This is basically a BREEAM outstanding building, but also with a really interesting approach in terms of energy use and trying to use the output from their industrial processes into energy generation, but also looking at resilience, which I feel is going to be one of the next big areas for us to look at, especially where resilience overlaps with sustainability. So perhaps a new MSc in the future there. Shalene's been with us for a long time, actually, and she's from Hong Kong, and her background is actually environmental engineering, so much closer to some of the stuff that we did the EDE, but she's really interested in passive design measures of buildings. This is a luxury tower we worked on in Bangalore, and there was a lot of thinking towards how can we actually help the architects detail some of the elements of the design to improve performance, to really make this building more future-proof, dependent less on air conditioning. So this is on the right here. It's typically what we go through a number of iterations to try to understand what's actually suitable for the project through dynamic simulation, testing these things, and then advising the design team on it, and then subsequently guiding them through active measures. She's actually working also on a project in China, which is going to be for part of the 2022 Winter Olympics near Beijing. And there we're actually looking at a much more wider site-wide strategy for the master plan, which is a mix of sports, residential, and hospitality, but really looking at pedestrian comfort and how external wind conditions and siting of buildings can influence natural ventilation strategies. And this is, some of the thinking behind it, but really thinking of changing the massing and siting and landscaping to improve performance outside of buildings and inside. Sarah has graduated about 6 years ago. She's from Portugal. She's also an architect. Sarah's dissertation was on building performance evaluation and POE, and she's actually been working on a POE project that we just finished now for Wilkinson Area. So we're part of the UK Green Building Council, and last year or 2 years ago, as part of the COP21, the UKGBC encouraged their members to come up with a pledge. And our pledge was to help other UKGBC members to better understand building performance. So we actually offered pro bono POEs. Wilkinson Air's pledge was to also do that, but for their project. So there was a match there, and we helped them understand performance in their office. They have some serious issues of occupant satisfaction and thermal comfort, as well as air quality and CO2 levels in their offices. It's a relatively old office with mechanical ventilation, but which is insufficient for the space. So what we developed with them is a ventilation strategy that could work for various seasons in the year to address both CO2 levels within the office, which is actually quite densely occupied, and thermal comfort. So it's really working with them to try to understand how we can also change controls for the various parts of the building. All of the thermostats were concentrated in a single location for the whole of the office, and some of them just under AC units, so the actual temperature shown them is completely incorrect. So it's really kind of working on how we can improve what's there. Sarah's also working on a passive house scheme for a master plan in East London, and passive house is also one of Sarah's passions, and she's recently gone through the passive house training. But it's an infill master plan to look at social housing opportunity in East London, and we were looking at a very smaller scale up to the master plan, but we're doing the passive house assessment, and it will be certified. So Yuja is from China, and he's a mechanical engineer, and has been working on a number of MEP projects. His most recent project is this 4-island resort in the Maldives, and which is a fascinating project. Obviously, it's a luxury development, but we need to achieve self-sufficiency in terms of energy, water, and wastewater, but also look at efficient systems that will withstand the climatic conditions. So Yuja was a very in-depth design and assessment of opportunities there, and he got stuck on a lot of the equipment strategy and selection. Nuno is from Portugal and is a civil engineer by background. And he's been working on this mixed-use scheme in South Korea, close to the airport. And the challenge here is to try to be independent of the grid in terms of utilities because the costs were very significant. So we developed a strategy for energy, water, and wastewater, which is now being further developed into an MEP design. Danila graduated not too long ago, and she's from Malta. Civil engineer. She worked on this project in Turkey, which has got a really interesting strategy in terms of water use and really understanding the various rainwater, greywater, and desalination output that we can have and use them as resources, both in terms of water consumption and in terms of amenities in the development. So we have, for instance, brine from the reverse osmosis plant being used for Dead Sea lagoons, which is basically kind of saltwater lagoons, and other kind of recreational features. So this is currently being under construction. Ridwan is an electrical engineer from Singapore, and he's working on a resort development in Niseko, Japan, in which we're looking at a number of technologies, including geothermal and a lot of passive design as well for the various buildings. And then we have two interns from your year. We've got Adele, who's from Canada, and her background is environmental science. And we've got Tessa, who I think she's actually from Belgium, so it's wrong there, but she's an environmental engineer. And they're working on this scheme in East London of 800 homes, in which we're doing a number of our environmental scopes, pre-planning, but trying to really understand how we can improve performance on the project. So some of the areas that we're actually going to be looking in the future, and I think are highly relevant to you entering the profession or maybe coming back to it or continuing in academia, is certainly looking at overheating and what's happening in terms of obviously effects of climate change, but also new policies that we're seeing in London, and London plan actually becoming much stricter, and that the links between overheating, air quality, and acoustics and energy performance are going to be key, and really trying to find a balance between those. Resilience, as I said, I think is an area of extreme interest, and we're going to see more of that. But anyway, some of these are quite familiar to you. Anyway, that's us, and I hope it gave you a flavor of what some of your old colleagues are doing, and thank you very much for listening.
Thank you, Ricardo. Our next speaker is Dr. S Van Berman. Esfand studied mechanical engineering at KNT University of Technology and Sharif University of Technology. Esfand continued his postgraduate studies at Nottingham University of Technology, where he earned a Master of Science degree in Manufacturing, Engineering and Management in 2006. He then practiced as a building services mechanical design engineer at Hurley Palmer Flat and senior energy consultant at Arcadis, UK, before joining UCL for doctoral research in 2010. Ladies and gentlemen, would you please welcome Dr. S Van Berman.
Hello everyone, thank you very much to Ricardo for a very interesting presentation. It's good to see what our ED graduates are up to these days. So this presentation is about one of our ongoing research projects called Top Total Operational Performance of Low Carbon Buildings in the UK and China. It's closely aligned with EDE key themes and also informs our ongoing teaching activities as well. So we thought it's a good example to present today. Several people, I have to say, are involved in this project. You can see the team involved in monitoring, and the project is led by Mike and Dayan. It's a collaborative research project between Tsinghua University and UCL. And really, the aim of the project is to have a holistic view of total operational performance, taking into account energy and environmental performance. So we see energy as the input to the environmental systems within a building, and indoor environmental quality as output. Ricardo already referred to the problem of the performance gap. Very often in research and in practice, we see that people treat these issues in isolation, energy performance gap, and then issues around air quality, thermal comfort, and other aspects of indoor environmental quality. The idea is to come up with a holistic view and a systematic view of these issues. You can see the work package involved in this project. So we started the project by carrying out a contextual review of the performance gap in both countries, in China and the UK, similarities, contrasts, and the underlying root causes. Work package 2 involves detailed monitoring and modeling of a number of case studies in both countries. So we have 8 case studies here in the UK. Our counterparts in China have more case studies to cover for climatic conditions, different climatic conditions they have in China. So they have 8 buildings in climatic conditions and climatic zones similar to the UK. And the rest of the buildings covers other climatic conditions they experience in China. So 24 case studies altogether, 8 in the UK, 16 in China. There's a bit of integration work going on at the moment, trying to learn the lessons from monitoring, feeding back the lessons to modeling or ongoing simulation work to formulate and develop some optimization schemes and scenarios for these case studies and more generic, if you like, solutions for the industry in both countries. In parallel, we have our another work package 3, which involves a system thinking approach and system dynamic approach to delve deeper into the underlying causes of performance gap, not the so-called first-order technical issues that we managed to uncover in work package 2, but more fundamental issues to do with, for example, soft factors involving an interplay between various players in the industry, the clients, designers, contractors, and policymakers, and so on and so forth. So that's system dynamic approach. So today's presentation is primarily focused on the outcomes of monitoring and some key lessons learned from that. So we also somehow touch on work package 3 and work package 4 as well. At the heart of it is this potential tension between energy efficiency policies and measures and potential or unintended consequences of these policies that have been uncovered in so many projects now. So we are talking about problems around, for example, overheating in low energy buildings in the UK, and also we have seen examples in China, problems around indoor air quality, which is quite serious in both countries, and for that reason has been the main focus of our work in terms of IEQ. So that's at the heart of the problem, the conflicts between energy efficiency measures and indoor environmental quality, and hence the system thinking approach to mitigate the risks. I've already referred to the number of case studies in terms of sectors. We focus on non-domestic buildings and large residential buildings, where even modest improvements in terms of environmental performance can, bring huge energy savings and environmental improvements. So we cover offices, schools, hospitals, and large residential blocks. 2 buildings from each sector in the UK and more in China. So altogether, in terms of the sectors, these sectors constitute a large cross-section of non-domestic buildings and large residential buildings in the UK. Very high-level breakdown of energy use per fuel for a number of these buildings for which we have relatively reliable design estimates. Don't touch on our ongoing modeling work, but these design estimates are the best estimates we have available in terms of baselining for these buildings, and hence you don't see all the case studies in the UK. We have only 5 buildings here. The best building, the best performer by far is an office building in Keynsham, close to Bristol, which has been subject to performance contracting and soft landings. It's a very interesting case that we come back to later on. Generally speaking, most of these buildings, as you can see, show the problem of the performance gap. So measured performance is very often significantly larger than the design baseline. The hospital case is slightly different, and that's because they have a very elaborate technical memorandum called ENCODE for energy and CO2 emissions, which goes well beyond what is very often carried out in accordance with the UK building regulations, so the regulatory calculations. And for that reason, in hospitals, we think we have more reliable baseline. So you have a more nuanced view of the performance gap there in two hospitals that we have. Schools are by far the worst case that we have, which is not uncommon. Schools and seasonal buildings have a tendency to waste energy during half-term breaks, extracurricular activities, because it's very difficult for FMs to take advantage of the zoning arrangement and make sure they isolate the zones that are not required, basically, in terms of heating, ventilation, and air conditioning systems. Given the uncertainties associated with design baselines, we also compared energy performance of these case studies, the non-domestic buildings here, against a good practice benchmark, with the underlying assumption that these new buildings should basically outperform good practice benchmark. The good practice benchmarks are based on the 25th percentile of DEC data sets, are quite up to date except for hospitals, which is based on ECG 72, slightly outdated. As you can see, again, a more nuanced view of energy performance gap here. Most of the buildings are actually performing relatively good when you compare it against good practice benchmarks. Major exception, again, is one of our schools, which is a campus-wide school, a number of buildings with central heating system, and we have problems in terms of inefficiencies in the energy center, but also heat loss in terms of the distribution of energy, in addition to problems with control of mechanical systems, especially during half-term breaks and extracurricular activities. In terms of our domestic buildings, the residential block, this is a residential block in East London. A community heating scheme is in place here, currently led by gas-fired boilers, but the intention is to integrate CHP plant in phase 2 of the development. Again, as you can see here, we managed to find reliable heat demand, measured heat demand information for 40 units, 40 dwellings within this block, 30 of which show higher heat demand than predicted. So this is heat demand, heat's basically delivered to the unit. It doesn't include the supply side of the things in terms of the community heating system. And it's mainly representative of building fabric characteristic, but also occupant behavior, which we believe is quite important in this case, and we can see a rebound effect in terms of actual heating demand being significantly higher than predicted. But also from supply side, preliminary data that we managed to receive from ESCO, energy service companies in charge of this scheme, suggests that the operational efficiency is very low, around 50% compared to 87%, which was assumed in SAP calculations. Fortunately, this is not uncommon, and we have been involved in another project. We were involved in another project in Southampton a couple of years ago, and we have come across these very low operational efficiencies. This is an ongoing project. There's a phase 2, so hopefully when they develop phase 2, the boilers will work at full load. They can manage and they can reduce the distribution losses, and the integration of CHP could also help. So we'll see whether or not we can manage to increase the heating efficiency, supply side of things. Going back to our best performing building, this is the Council's office building in Keynsham. And from process view, it's quite interesting because this is the only building which has been subject to performance contracting, energy performance contracting, and soft landings. The question is whether or not this process can really close the performance gap. So far, we have only focused on energy. I'm aware of it, but we'll come to indoor environmental quality and more specifically indoor air quality shortly. So the idea here for this building was to have a deck A after the second year of operation. So you can see asset rating, A-rated asset rating or EPC. The idea was also to have a deck A rating after the second year. That was an operational target in the contracts, and they didn't quite achieve that. As you can see, the rating was B. It's not that bad compared to other buildings, but they didn't quite get there. You can see the energy budget set out up right-hand side. This was the energy budget set up by designers and contractors before completion of the building. First year, second year of operation. It's quite interesting to see the impact of soft landings and building fine-tuning during the early months and years of operation. Significant saving in terms of heating, energy use, lighting, automated lighting control. and also schedules of operation for heating, which also has had a positive impact in terms of auxiliary energy use. So pumps energy use has been significantly reduced. You can see the positive impact of soft landing. Energy budgets, some of them are very ambitious, probably very difficult to achieve in practice, especially lighting. Heating-wise, they experience a lot of problems, and also some problems around thermal bridging at construction junctions. So really, heating demand is higher than what was anticipated at design stage as well. A combination of architectural and engineering issues there. More importantly, you can see net electrical demand of the building, and it doesn't follow the usual bell curve shape that you would expect from electrical demand curves, and that's because there's a sizable PV installation here, 230 kilowatt peak for an office building around 7,000 square meters. So it's really influential in bringing down electrical demand, and this really gives us a hint that to achieve deck A now, they have to attack the baseline demand to get there. But also, there's a more fundamental question, because this graph, the electrical demand, shows us that the deck, to a large extent, is dependent on this PV installation. And indeed, if you exclude the impact of PV, you realize that there's a significant gap, not something that the deck, comparison between the actual deck and the expected deck would tell you. So gas consumption is almost twice, 107% more gas and around 50% more electricity. So you can see a significant gap. It's quite important. Fundamental question is whether or not DK is a good target, because this model now is being used in the industry. It's a very niche segment of the market, but the main contractor involved in this job actually they have used this model in another project in Leicester quite recently, and this time successfully. They managed to get DK. But the question is whether this is a good target, or whether we can complement it with other key performance indicators that also cover energy demand and primary energy use in addition to CO2. That's a good lesson learned. But apart from that, the main lesson learned here is quite important to set out these operational energy targets right at the start of the project, and try to identify key determinants of energy performance, energy efficiency measures, and protect them throughout the design and construction from value engineering process, and also soft landing measures and fine-tuning during early stages of post-occupancy. This could be really influential compared to other buildings that have not been subject to soft landings in our sample. So that's energy. And that's good news from process point of view. The downside to it in this case is we notice that in terms of indoor environmental quality, and again, examples presented here are to do with indoor air quality, but we have some issues around thermal comfort as well. Effectively, these were not taken care of to a large extent by the main contractor as part of the performance contract. So they were really preoccupied with achieving that decade target, to the extent that when we uncovered some issues to do with high CO2 concentration levels on one level, the second floor of that building, as a result of some malfunctioning automated vents that were not operational. As you can notice, this led to CO2 levels well above 1,500 ppm set point set for that building. They were aware of it, but effectively they didn't do it. And when it came to the heating season, past heating season, the idea was basically we can close the vents, and that would help achieve our energy target in terms of heating energy. So you can see the conflict between indoor air quality and the energy budgets, and how the determination to get there in terms of deck A might have knock-on effects on indoor air quality. So that was the zone with problematic automated vents, but also we had issues around PM2.5 concentration in other zones. So this brings about the whole issue of indoor air quality and how we can improve indoor air quality in addition to saving energy. We are also contributing to the ongoing activities in International Energy Agency Energy in Buildings and Communities program, Annex 68. And this is the result of metadata analysis carried out on a large statistical sample of residential buildings here to work out the contaminants with high concentration levels in low energy buildings. The definition of low energy buildings here is basically based on the age of the buildings. So the cutoff points, for example, in the UK and EU was the implementation date of Energy Performance of Buildings Directive. And you can see the species, the contaminants with risk of having high concentration level higher than exposure limit values. So we identify these species and we try to monitor these by a combination of active monitoring but also passive sampling in terms of VOCs across the board in our buildings. Now this study was carried out in residential sector. We have done some complementary research in hospitals, offices, schools, but this is the minimum number of species that we managed to monitor. Across the board, there are some additional species in other building types as well. And the idea really is, from theoretical point of view, to integrate these so-called energy ratings. You're familiar with these type of energy certificates as a result of the implementation of the EPBD, with indices that show us the IEQ quality of a building, in this case, specifically indoor air quality. This could be comparing actual measurement of various contaminants against exposure limit values, or disability adjusted life years, which is a more direct reflection of the health impact of concentration level of these contaminants. The graphs you see here is based on the dwellings residential sector in France, the average concentration levels. But in terms of health impact, it's quite important to know that PM2.5 is by far the worst one. And that's applicable to other contexts as well. And again, this is a very good example, which brings us now to the UK and specifically London, just an example. So the current EU legal limit in terms of long-term chronic level or annual mean is 25 microgram per cubic meter for PM2.5. And you can see the distribution of outdoor PM2.5 in London. And WHO guideline limit is much more stringent, is 10. So with EU legal limits, it's quite easy to come up, for example, with a natural ventilation strategy. And you would be able to meet the EU limit. With WHO, it would be very difficult, even the outer skirts of the city. And that poses a challenge, which one is the right one in terms of our environmental design strategies. Just an international view here, so you can compare the EU legal limit against North America, United States, and Canada. Actually, EPA in the United States, quite recently, a few years ago, they brought it down to 12 microgram per cubic meter, based on empirical data and epidemiologic evidence. In China and India, large population, rapidly growing countries, significantly higher even than the EU legal limit. And the country with the least limit is actually Australia. So if we try to project or estimate global premature mortality rates attributed to these exposure limit values, you can see coming from the EU legal limit of 25 to what we have in North America and or Australia, you can easily halve the number of basically mortalities. So it's quite important in terms of health impact, which figure we choose in terms of our target PM2.5, and hence the choice for ventilation strategy. Now going back to our case studies, this is again our office building in Keynsham, naturally ventilated buildings. You can see the manually operable window. The higher level is the automated vent that I was talking about. So we have problems there. Natural ventilation strategy, when we monitored outdoor source contaminants, so PM2.5, NO2, in addition to CO2, which is very often used as a proxy for air quality in the UK, the interplay between CO2 and other contaminants was quite interesting. You can see the zone, the problematic zone with high CO2 levels has the lowest NO2 concentration levels, and the same pattern applies to PM2.5, which makes sense because the zone is not quite exposed to outdoor air. But it's also this interplay between CO2 and other contaminants brings the idea of optimized control strategy based on outdoor pollution and not only CO2. And we are not doing intervention study there, but we have already started developing this strategy in modeling environment, in virtual environment. It could be quite effective both in terms of energy efficiency, but also to make sure that we have optimal level of indoor air quality depending on how you define the indoor air quality proxies and try to minimize the health impact, the adverse health impact of this. Moving on from a case study with natural ventilation strategy to a mechanically ventilated case. This is again in Bristol, not that far from the first building, but this one is a mechanically ventilated hospital, full mechanical ventilation, sealed envelope, no windows at all, operable windows at all, 10 to 12 air change rates per hour. Again, CO2 levels quite low, which is not unexpected given the air change rates, 10 to 12. Its maximum is around 800 ppm, quite consistent with the design intent. High-grade filtration, very effective in terms of PM2.5 and other microparticles as well. You can see the indoor concentrations are almost negligible, so it's quite important, quite effective. At the same time, you can see the external values are quite high. Quite effective in terms of microparticles. In terms of nitrogen dioxide, sorry, this should be NO2 as you can see under the graph. That's a different pattern, and you can see that indoor NO2 closely follows outdoor NO2. And on some levels, the concentration levels actually are quite high, higher than the chronic level set out by WHO for NO2, which is 21 particles per billion. But forgetting about absolute values, what this graph tells us is there is no effective measure to control NO2. That's the main issue. It's quite interesting because NO2 is the limit for NO2, chronic limit for NO2 is actually stated in the approved document Part F. So it's part of our building regulations. That 21 particles per billion is specifically mentioned in approved document Part F. But it's not quite clear in that approved document and other documents that how you can get there. What are the means to make sure indoor concentration levels of NO2 are not greater than 21 particles per billion? So there's an issue there. And in that regard, and of course the problem with NO2 is you can't use conventional filtration like you do for microparticles, so F9 filtration or HEPA filtration is not really effective. We need a chemical process to be able to remove NO2, be it scrubbers, which could be quite justifiable actually in a campus-based hospital in this case, but also activated carbon filters could to a large extent reduce the concentration level of NO2. And on that note, it's quite interesting to note that in the well building standard now, there's provision of at least allowing for rack space for future implementation of carbon filters or a combination of particle carbon filters in air handling units. So even if the current design strategy is not inclusive of that, it's quite important to allow for that rack space for future, which is quite progressive in that regard based on the evidence we see. And don't forget, this is a hospital. So it could be really problematic. Now, this is a time series based on around 2 weeks, perhaps less than 2 weeks data, but of course we did this monitoring for the entire heating season. This is a past heating season, and this is ongoing. For the entire heating season, you can see the hospital is the worst case scenario compared to office and school here. And in terms of indoor concentration levels, the median and average is just below that chronic level, but you have significant, many data points and episodes higher than that, which could be problematic. So far we covered PM2.5, examples of PM2.5 and NO2, externally driven air pollution. In terms of internal sources, formaldehyde again is by far perhaps the worst one in terms of health impact among VOCs. It's quite interesting to note that across the board in all residential samples, formaldehyde concentrations were around 3 times the limit, chronic limit set out by WHO. So it seems that definitely there's a problem there in terms of source control, in terms of material selection, also materials available, the emission factors, the real emission factors of VOCs available in the industry. And going back to the graph that was just presented from Annex 68, IEA Annex 68, the entire statistical sample that we have, around 20,000 buildings on that graph, formaldehyde concentration levels are above chronic level, WHO chronic level. So this is an industry-wide problem, and we have to tackle it. We came across the same problem here in the UK. Non-domestic buildings, mixed picture. Our school was fine. Hospital was fine, but it was more to do with the ventilation rates rather than the material. In the office building in Keynsham, again, the actual formaldehyde concentration level is significantly higher than WHO. This is just one example from 2 flats in East London, And you can see formaldehyde levels compared with the WHO limit. We have problems in terms of benzene as well, but of course benzene is predominantly externally driven. So, in terms of conclusions, I think the 3 key lessons learned so far from the project. From process point of view, it's quite evident that performance contracting and soft landings could be quite effective in terms of closing the performance gap. Soft landings framework, BISRIO soft landings framework is great, but it's not perhaps as specific as it should be. So it's quite important to define specific KPIs, robust KPIs, ideally within an energy performance contract. But it shouldn't be confined to energy. So basically, our message is it really should be energy plus environmental performance contracting. We really need to make sure we get the environmental side right as well. So that in terms of process improvement to close the performance gap. In terms of outdoor sources of pollution and what we could do indoor in terms of specifically ventilation strategies, there are opportunities to optimize ventilation strategies based on outdoor pollution. So it's not a question of natural or mechanical ventilation. It really depends on building context. But whatever ventilation strategy we decide in the end, we should be able to mitigate these risks by means of optimizing control strategies for health. And last one is to do with indoor sources of pollution. Specifically, formaldehyde comes up both in IAEA research and our own research here in the UK as a major issue. And it's quite important to strengthen the existing standards, materials available, but also in reality for rare projects, we might as well increase the ventilation rate during the early stage of post-occupancy and then throttle it back, revert it to more long-term and normal ventilation rates following a seasonal commissioning. So there are practical ways to make sure that during that off-gassing period, we maintain a good level of indoor air quality regardless of the problems, any potential problems with materials. So it's a combination of source control, but also optimized ventilation strategy that needs to be taken into account. That's it. Thank you very much.
Thank you, Esfand. Our next speaker is Florence Lam from Arup. Florence is an Arup Fellow and leads Arup's global lighting design practice. Her particular expertise is in daylight, visual perception, and holistic lighting approach play a key role in many of her projects, from museums to airports, bridges to city precincts, all over the world. She was responsible for delivering a range of lighting projects for the London Olympic Games in 2012. Florence was named the Lighting Designer of the Year at the UK Lighting Design Awards in 2013, and she's also the recipient of the Lighting Award from the Society of Light and Lighting in 2014. Ladies and gentlemen, will you please welcome Florence Lam.
Hi, good afternoon, and thank you, Peter, for inviting me to this afternoon event and join the celebrations for the 30 years of the Light and Lighting and 40 years of the IDED. In a different light, this is my title, and I'm going to speak from my perspective as a lighting designer of the last 20, 30 years. And the brief that I have is do a bit of reminiscence, look at the past, present, and the future. So that's what I've done. And I hope it's going to work out. So, people first. Currently within Arup, we have about 130 plus lighting designers around the world. And about 15% are ex-Bartlett, so Bartlett alumni. And they're not just all in the UK. And many of them has actually been not just working in London, but also around the world. Now, currently, I've got people in Tokyo, New York, and Sydney. And one or two of them is actually retired as well. And I'm really pleased to say this year is the 40 under 40 of lighting design being recognized for the next sort of up-and-coming generation. There's 4 of them are from Arup, and 3 of them is actually, out of the 4, are from the Bartlett student as well. So this is a bit of the lighting world. We started the lighting practice space in London back in 2000, 2001, so that's about 18 years ago. And over the time, we have sort of grown and spread the teams around in 9 different countries and in the UK in a number of cities as well. This is my lighting world, quite colorful. But one that I want to really focus on, and the bit that I really very proud of, is the team is also very much focused on daylight design. And daylight is not just about studying and doing analytical work, but actually engaging with architects very closely in day one on project work and helping to shape the form of the building from following functions. And you can see this daylight design can actually be applied to a multitude of different kind of projects, not just museum art galleries, not just in offices looking at facades, but actually shaping a lot of forms. Some of them can be quite dynamics as well. So how did it started? 1988. I was still in the middle of an engineering degree at Cambridge, and I just found that if I'm going to graduate in engineering, I just find it still a bit quite dry. And where's the people bit? How do I actually link in what I'm learning into practice? So I was looking around, and I found lighting at the Bartlett, and this is the kind of syllabus from the perspectives I received at the time, and those are the kind of elements that was offered. Like, great, it sounds all non-engineering in some way. I'm going to learn something out of it. And then fast forward, just to prepare this talk, I look at the prospectus today that what is on offer, and it's even better. I wish I had that 30 years ago. But this is the kind of things that we now talk about, the technical and the creative part of the course offering. Lighting needs to straddle both. And also the outcome is about people's human experience. And those are the subjects being talked about. Again, comparing the days when I first started, the old IBM 386 is what I first had, to the multitude of different analytical tools that we are now using, and something that could be quite dynamic in terms of computer optimization being used for looking at how we can optimize site massing to get the best daylight quality on site, but also a chance for building to get the right kind of light as well. And something that I learned that I've never learned before in my undergraduate course is making, hands making, actually making things with any materials that you can have. The middle image is actually showing the luminaire design that I did with my partner at the school that year, and Peter is actually in the same cohort as well. So you remember those are days when we had to do luminaire design and actually make one as well. But nowadays in practice, we still do a lot of hand making, mock-up in a different way. That's the old sky lab that we have, the old artificial sky, very rectangular box, if you remember that, Peter. And now something much better, and even better, I've just heard that you've got a new one at the UCL East, and I'm just looking forward to visit. Invite, please. In the lighting industry, so I'm going to talk about 30 years, I have to talk really, really fast, because it is one of those industries that has been very dynamic, has encountered lots of innovations, and a few of those actually are big disruptions. And of course, the Edison bulb is the first disruption, the electric bulb. And why is it disruption? Because it's actually changed a lot in terms of how we work, our lifestyles, but also created new markets from a manufacturing point of view, but also profession point of view, lighting engineering, lighting design. It's now required. And since then, the evolution of different light sources, things that we have to learn, or I have to learn at the time, on different kind of light sources, fluorescent, high-intensity discharge lamps, all kind of size and shapes, every single performance, colors, phosphorus, all the chemicals bit. Lots of things to remember, and lots of things to bear in mind when we actually design with these fixtures, and these fixtures go into fittings as well. Isn't life easier these days? All we are talking about now could be just LED. LED could have been the holy grail of everything. But so long as LED is just serving the lighting for the sake of lighting, it's like a phone just for phone purpose, a watch just being a watch. Then it's not disruption, it's just innovations like the evolutions of many other light sources that came before it. And the lighting course itself has brought me into the world of architectural lighting, and understandably, this profession is about bringing light, putting light in a space for people. The light will interact with various finishes within that space and create an experience for the people. So that's very simplistically talking about what lighting design is about. And that's still at this moment is the mainstream about lighting design. Things has changed, move on into talk about sustainability, LED into sustainability, intelligent lighting. That is still within the sort of frame of architecture, lighting, and this is still, I would say, innovations come along, but they are sustaining, they're not disruptive yet. But what's become disruptive is when we talk about smartness, smart connected lighting. So started a few years ago. There's now smart lighting is not about illumination anymore. It is about this possibility of having an infrastructure that carries data along and open up a lot of possibilities how one can use those data by overlaying some kind of applications over it. So at this time, we may not be talking about lighting business anymore. This is a time when smart lighting is no longer just about lighting. It is also the time when smartphone or smart watches is not about being a watch to look at time anymore. So that could be an analogy there. But if we are careful not to just let it go and become something in a connected business, and what does it mean for lighting? How can we do more? We have smart lighting, but we also have smart devices. Each of us probably have one or even more than one in our pocket or in our bag somewhere. Is what the opportunity is actually using lights to be even more engaged with people rather than just through the vision side, is other interactions, other things that we can see some convergence, and what we can do more about people being more engaged, interacting with it, and creating more of the experience design, and also using the technology to be able to have feedback on people's behavior. How would those additional opportunity would actually change the way how our lifestyle could be? And that would be the innovation in terms of disruptive innovations. But is technology everything? Is that the answer? So what is the question? So what is the roadmap to the future? A few months ago, I asked the questions. I'm not sure why it's not working very well here. I asked the questions of, will AI actually redesign the lighting design professional? And I have Jemima coming to Arup when we co-hosted it with SLL, posing that questions. Because we need to be aware of it. But then who is the lighting designers? We have lighting engineers, we have our discipline being called designers, light architect, Licht planner, if it's coming Germany, and also the French way of calling it lighting lumiere conceptual. So we look at those. So what are the profession? The profession is really about, you need to embody some basic skills and knowledge about light, the physical element of light, the dual properties of light, that is the particles as well as the wave. And that's how the knowledge about the optics is important. The knowledge about the color, the composition of color, the color quality is important. But more importantly, light is not just an enabler to see. It does have a big impact when light actually goes through someone's eye with people. And it also has this sort of non-visual, the biological effect on people as well. And then also how we're able to see and admire light is something as a human being we learn through interacting with the world around us as we grow as well. It's the same as how we learn to walk, how we learn to talk. So it's quite interesting is the depth of the subject is beyond just the technology, beyond a set of numbers of how much light actually arrives with a certain service. So there's a lot more going to it. And as a profession, when we look at building design, we also need to know a lot of soft skills of how to embrace many different issues that's going to design, and that involves critical as well as creative thinking. So the soft skills is not just about the precise knowledge of something. And of course, to practice, we need to understand the workflow, the processes, the deliverables. So there's a hard skills that one needs to learn as well. But what I'm pleased to say, so I'm still looking back, is to be involved in a built environment, design and engineering, is not just something that I had to deal with is ugly and important. With lighting, it's actually can be very beautiful and important. Beautiful in a way is when it's actually a positive outcome, and how it impacts on people and the society and communities overall is sort of 3 levels. One is the physical, be able to see, the vision side of things. The second is the physiological, the non-visual element, how is the photobiology side of people, the light affecting that, and also the chronobiology side of things. And then finally, the psychological aspect is still a bit of science to be discovered, to be analyzed, rather than just a bit of black art. It's just embraced by quite a few lighting designers as well. And to achieve the best lighting outcome, I'll talk about technology and knowledge itself, one also needs to acquire and develop a language of light that's used to express about spaces, how to articulate, how to create a space that you can influence and shape people's experience and memories in a space, so the characters of light. So I'm just going to run through a series of images, some of the projects that I like to sort of call it by a way of how these characters of light actually delivers a project. How, for example, this one, create the delights for people. How we use light to tell stories about traditions of cultures of Abu Dhabi. How we use also light, I think it's this reformatting problem. I don't know where my slide is now. So skip one. How we use light to guide people in a sort of public realm space, connecting people to space. And the heritage side of lighting, using light to also connect people to the history, to the past. And also celebrating achievement, and there's supposed to be an image of a Mercedes-Benz hero light in there. So you just imagine. And I don't know whether it's going to carry on like that. Should have just used my slide. Okay. Yes, just imagine that's the aquatic center. Okay, the green line, sustaining health for plants, but also sustaining health for people, health and well-being for people, for human performance. And in the public space, promoting inclusivity and also encouraging social interaction. For safety, it's not just about more light is better. It is how you can actually entice people to dwell in the space so that they spend time there. Eye on the street, you see people seeing you, you feel safer. So there's a sort of more deeper logic of how you can actually use light to also build resilience in cities and in communities as well. This is a slide that sometime I use when I have to talk through about my career and seeing how over the years I have to acquire more knowledge in different fields and how I make myself a better designer in some way, but also more fundamentally is more useful in a way of what I'm doing and what the team is doing, the real purpose behind design. And so the size of these bubbles is probably reflect a little bit of how I'm feeling at the time when I was creating this slide. But more importantly, is for built environment, there could be many, many different solutions. There are good ones, bad ones, indifferent ones. But the art of creating a good solution does involve creative activities, which starts from imagination, intuition, and deliberate choice. And the deliberate choice is based on what you know. Of course, you need to have the skills as well, but also is the ethical value. And I think that's very important to drive ourselves in the future. Lighting for humanity. Stephen mentioned that it's a very important day today because the longest days of the year, summer solstice. But I also like to say today is the the World Humanist Day as well. So I was looking at what the humanism is about. It's about sort of have a philosophical life stand and also a means to affect change in the world. So today is great to have people coming together and we gather together and to promote the positive values of humans. And I think lighting can really play a huge part of it because sometimes lighting designers could be seen as jewelers for the riches. I think someone might have asked similar questions to the earlier speakers before. Yes, we can be, but also as a profession, it is time for us to be able to channel what we know and how we can influence in a bigger way to impact and create and shape a better world as well. It's easy to say better, so what does better mean? And I think I would like to sort of flag up, I'm using the remaining time, just flag up the UN Sustainability Development Goals, there's 17 of them, and they are there, they're published in 2015, and they sort of set a vision for 2030 to achieve means of what we do to ensure we have prosperity for all, no poverty, but also in a way is protect the planet in the kind of high-level ambition. And we need to promote that. From a lighting perspective, it's quite easy that I can put daylight into pretty much most of the boxes in there, how daylight can influence. But what about electric lighting? What about architectural lighting? This is, you can see the pictures on your left. That's Hong Kong. I'm from Hong Kong originally, and so this scene is not unfamiliar to me. And today, this urban nightscape has become a new arena for a lot of world cities to compete against each other. And there's also a belief out there is about the brighter, the better, the more illuminated skylines, will actually becomes a model of progress and prosperity that a lot of cities look up to. And this attitude of more light is better, I would say, has been leading to a lot of, or too much light everywhere. And and at the same time, from a human perspective, we know that both light and darkness are important for people. So what's our responsibility, what we can do? Well, light is fundamental to humanity, from securing safety, building resilience, enabling inclusiveness, equality, but also enabling social interactions and hence achieving prosperity. Yes, it ticks all these boxes. But with cities, with urbanization and cities shifting towards more of a 24 hours operations, changing demographic as well, what do we think about nighttime? Is it just plan, design for the day? That's what architects and urban designers sometimes do, and I think probably most of the time they do. And just hopefully, nighttime you just switch on the street light and there you go, everything will be fine. I think it's a loss of opportunity. Now with the technologies that we can, with the LED and all the smart controls, etc., we can use these new technologies, put additional nighttime design thinking to cities. So properly design for the 24 hours, doesn't mean light all the time, but design for darkness as well, so that we can actually articulate the different shades of night properly and designing for the cities. So as designers, we love to celebrate light in the urban context, but we need to think beyond functional safety, beyond just beautifying cities. And there is more that we do. And when we talk about creating a sustainable, livable, drivable cities, etc., how are we measuring our success? I don't think we have quite the skills yet, but there's skills and knowledge elsewhere. How do we measure social return on investment? We're putting technologies that sort of come with the money side of things as well. So I think we are now at the point that this open up a new opportunities to actually look at what we can research and what we should be more researching, putting applied research in places that can help us to answer those questions so that we know the outcome is not just a more beautiful spaces or brighter space. The outcome is how we can make sure the human will perform better, health and well-being to be guaranteed, and achieving those sustainability goals. And who is going to orchestrate and coordinate this effort? Because it is a transdisciplinary effort. It's not just a lighting designer, because there's so much that we need to talk about, and I'm quite sure later on we have a panel session that we can have that discussion more thoroughly explored. So at this point, I'll finish my talk. Thank you.